Hi all, welcome to another session of Boil Chem Tutor. In this session, I am discussing something regarding diazonium salt. In that, I am discussing mainly what is diazonium salt, how it is prepared, and what are the chemical reactions undergoing the diazonium salt. Diazonium salt have general formula ArN2 plus X negative, where X negative can be chloride, bromide, nitrate, sulfite or bisulfate or any simple anionic group. And the N2 positive, that is N triple boot N positive group is known as the diazonium ion. Why it is termed as diazonium ion? Because it contains two nitrogen atoms, and these nitrogen atoms are otherwise called as azole, and onium is derived from the ammonium ion. That is why it is termed as diazonium ion. They are named by adding the word diazonium to the parent aromatic compound to which they are related and then followed by the name of anion. Suppose our example is C6H5N2 plus Cl negative. Then it can be named as benzene diazonium chloride. Again, another example we can note it is the C6H5N2 plus SO4 2 negative. Then it can be named as benzene diazonium sulfate. So let us discuss how the diazonium salt are prepared. The diazonium salt are prepared from aromatic amine, that is aniline. When aniline is treated with nitrous acid, that is HNO2, at low temperature, we are getting the diazonium salt. And this process of preparing the diazonium salt is termed as diazotization. And the reaction is carried out at low temperature. Why? Because after getting the diazonium salt, it may easily react if the reaction temperature is high. That is why the reaction is mainly carried out at low temperature. And one more important point to note is that the nitrous acid HNO2 is highly unstable. Therefore, we are preparing in situ by the reaction between sodium nitrite, that is NaNO2, and any acid medium. So let us discuss the mechanism of the diazonium salt formation. So first step in the mechanism is the formation of a nitrous acid by the reaction between sodium nitrite, that is NaNO2, and HCl. That is a simple acid-base reaction. So after the formation of a nitrous acid, that is HNO2, it again reacts with the acid present in the reaction so that oxygen atom get protonated again and result in the formation of a water molecule, which get leaved easily, that is it acts as a better leaving group. So it leave easily and result in the formation of a nitrosonium ion. So after the formation of a nitrosonium ion, that is NO positive, it start attracting the aromatic amine, that is aniline. And this aromatic amine nitrogen atom is having a lone pair electron and it start attracting the NO, that is positive, and nitrosonium ion and creating a bond between them and result in the formation of this compound. So after creating a bond between aromatic amine and the nitrosonium ion, it will react with the base present in the reaction. And the base has an ability to abstract a proton from the nitrogen atom and result in the formation of a nitrosoamine. That means the lone pair electron present on the nitrogen is again retained. So after the formation of a nitrosoamine, it reacts with the acid. Again, one more important point to note is that diazonium reaction is carried out in the acid medium. So there will be plenty of acid in that reaction. So nitrosoamine start reacting with the acid. Then the lone pair electron present of the nitrogen atom fall down between the two nitrogen atom and result in the formation of a double bond. And then nitrogen oxygen is having a double bond and which start grabbing a proton and then the base will be expelled and result in the formation of this compound. So after the formation of this compound, it again react with the base. So that the base, we can abstract another proton from the aromatic amine and so that the lone pair electron will be again retained on the aromatic nitrogen atom and result in the formation of N-hydroxyazo compound. So after the formation of an N-hydroxyazo compound, then it again react with the acid. Then oxygen start protonating again and result in the formation of a water. Then the water molecule will be easily left out and then the aromatic nitrogen containing lone pair electron electrons start to shift and result in the formation of a triple bond and with a positive charge on the nitrogen atom, that is diazonium ion. So this is the overall mechanism of the diazonium salt formation. So first step is the formation of a nitrosonium ion and then creating a bond between the nitrosonium ion and the aromatic amine and then involve a series of acid-base reaction and result in the formation of a diazonium salt. Considering the physical properties of diazonium salt, the dry diazonium salt are crystalline solid and are highly unstable and they have a tendency to explode in dry state. So they are seldom isolated. But in their aqueous solution, they are useful for preparing various aromatic compounds. One more important point to note is that the diazonium salt are stable in cold water, but they are highly reacting in hot water. Next, we can discuss the chemical reactions of diazonium salt. So the reaction given by the diazonium salt are classified into two categories. First category is the substitution reaction. That is, in this reaction, the diazo group, that is N2 group, is removed and another group is substituted. Another type of reaction is the coupling reaction. In this reaction, the diazo group, that is N2 group, is retained. Let us discuss the category of the substitution reaction. In that, we are first discussing the preparations of phenol. That is, how from diazonium salt phenol is prepared. So when diazonium salt is warmed with water, we are getting phenol. That is, in this reaction, nitrogen is eliminated or nitrogen is removed from the reaction and an OH group is attached to the benzene ring. Next reaction is the preparation of benzene from the diazonium salt. So when diazonium salt is reduced with hypophosphorus acid, that is S3PO2, in the presence of a cuprous ion, we can get benzene. Instead of this hypophosphorus acid, that is S3PO2, we can use ethanol also. So when we are reducing benzene diazonium salt with hypophosphorus acid or ethanol in the presence of cuprous ion, we are getting benzene. Next is the preparation of halobenzene from benzene diazonium salt. So when benzene diazonium salt is warmed with aqueous solution of cuprous halide, that is can be taken as copper chloride CuCl and HCl or CuBr and HBr, we can get halobenzene. And this reaction is having a name that is termed as Sandmeyer reaction. We can prepare easily chlorobenzene and bromobenzene from Sandmeyer reaction, but we cannot prepare iodobenzene and fluorobenzene from Sandmeyer reactions. Again, the diazonium salt can be replaced by cyanide by Sandmeyer reaction by using copper cyanide, that is CuCN and HCN. Again, when diazonium salt is treated with copper powder and an halogen acid, that can be HCl as well as the HBr. So when benzene diazonium salt is treated with copper powder as well as the HCl, we are getting the chlorobenzene. Similarly, copper powder with HBr, we are getting bromobenzene. And this reaction is also having a name that is termed as Gattermann reaction. So one important point to note is that in Sandmeyer reaction, we are using cuprous chloride or cuprous halide. But in Gattermann reaction, we are using copper powder and an halogen acid. So by Sandmeyer reaction as well as Gattermann reaction, we can easily prepare chlorobenzene as well as the bromobenzene. But it is difficult to prepare iodobenzene or it cannot prepare iodobenzene as well as the fluorobenzene. So in order to prepare iodobenzene, we are treating the benzene diazonium salt with potassium iodide and just warming and we can get iodobenzene with the elimination of a nitrogen molecule. So if we want to prepare fluorobenzene, we have to first treat benzene diazonium chloride with fluoroboric acid, that is HbF4. So benzene diazonium chloride is treated with fluoroboric acid, that is HbF4. We will get benzene diazonium tetrafluoroborate. Then which on warming we can get fluorobenzene. So this reaction is also having a name called Balz-Schiemann reaction. So if we want to prepare a nitrobenzene from benzene diazonium salt, we have to first treat the benzene diazonium chloride with again fluoroboric acid, that is HbF4. Then we can get benzene diazonium tetrafluoroborate. After getting the benzene diazonium tetrafluoroborate, we have to treat with sodium nitrate in the presence of copper powder. Then we can get nitrobenzene. So suppose if you want to prepare a biaryl compound, that is biphenyl, we have to treat the benzene diazonium salt with benzene in the presence of a base. Then we can get a biphenyl. And this reaction is having a term that is termed as a Gomberg reaction. And again, in this reaction, nitrogen is eliminated, nitrogen molecule is eliminated, and this is also a category of substitution reaction. So let us discuss the next type of reaction, that is coupling reaction. So in coupling reaction of diazonium salt, here N2 group, that is diazo group, is retained. And diazonium chloride undergo coupling reaction with electron-rich compounds like phenol and amines. It results in the formation of an azo compound and that are highly colored and that result in the formation of various dyes. So let us discuss the coupling reactions of benzene diazonium chloride with phenol. So when benzene diazonium chloride is coupled with the phenol under slightly alkaline conditions, we can get a para-hydroxyazobenzene, and that is termed as phenol orange because it is having an orange color. That is why it is termed as phenol orange. So let us discuss the mechanism of this reaction. That is, first step in the reaction is phenol when treated with alkali. That is, phenol is highly acidic in nature, therefore it can react with a base. Then it will abstract a proton and result in the formation of a phenoxide ion. And this phenoxide ion is highly resonance stabilized. So the negative charge from the oxygen start to shift and it will shift to the ortho position in the first resonating structure, and then from the ortho position the negative charge again shift and it shift to the para position in the second resonating structure. In the second step, the negative charge present at the para position of the phenoxide ion start attracting the benzene diazonium chloride and then result in the formation of a bond and with the expulsions of a chloride ion from the diazonium salt. And in the last step is the expulsions of a proton from the para position by a base and result in the formation of an azo compound, and the aromaticity is again retained in the phenol ring. Similarly, when benzene diazonium chloride is treated with another electron-rich compound like aniline, then it results in the formation of another dye that is called aniline yellow. And one important point to note is that this aniline is basic in nature. So we are carried out the reaction under acid condition, that is slightly acid condition. Then we are getting the compound that is para-aminoazobenzene and it is otherwise termed as aniline yellow. And last reaction is a reduction of benzene diazonium chloride. So when benzene diazonium chloride is reduced with stannous chloride, that is SnCl2, in the presence of acidic medium, we are getting phenylhydrazine. And in place of stannous chloride, that is SnCl2, we can use either sodium sulfite, that is Na2SO3, or zinc in the presence of HCl. And if we are using zinc in the presence of HCl, it undergoes two-step reduction. That is, first step it results in the formation of phenylhydrazine and then it again undergoes reduction and it reduces to aniline. So that is all in this session. Hope you like this session and stay tuned for the next session. Till then, bye.